Good morning, everyone. Hard to believe, but we are starting the second day of our big conference, Theories and Practices of Art and Design, Social, Cultural, Economic, and Political Contexts, which is organized by the Doctoral School in Art and Design, High School of Economics, and Art and Design School, High School of Economics. Today, there will be a few panels working, and you have program to navigate and to see what interests you most. But now I'm absolutely thrilled to introduce our keynote speaker, Kjetil Fallan, Professor of Design History at the University of Oslo, co-founder of the Oslo School of Environmental Humanities. In recent years, Kjetil's research has sought to bring together histories of design and the environment, and he's the author of Designing Modern Norway, A History of Design and Discourse, Design History, Understanding Theory and Method, the editor of The Culture of Nature in the History of Design, etc., etc., etc. Today, the paper Kjetil is going to present is called Designed in Denmark, Assembled in California, Windmills and Lands of Plenty. Kjetil, hello and welcome.
Thank you so much, Ludmilla, for that introduction and for inviting me to this event, which I'm very happy to contribute to. Yes, I thought I'll hang on, I'll just share my screen here. There we go. Right, so I thought I'll start by a little personal anecdote. A couple of years ago, I spent a sabbatical year in California and was very fascinated by the Californian landscape and also the Californian design culture and design history. And I was there to continue my research on the history of ecological design. And of course, as anyone who's traveled in California knows, you have these massive wind parks, wind farms full of windmills. But I was surprised to learn actually that the majority of these windmills that are, all over California, they're actually Danish. So I was intrigued by this and wondered, why is that so? So I started to dig into it. And these objects, they fascinate me for a number of reasons. One of which is, of course, that they don't normally figure in the canon of Danish design. When you say Danish design, you normally think of a beautiful teak chair or something, right? Or some silverware. You don't think of massive windmills. But they are, of course, objects of design. And they are, of course, an important part of Danish design history, especially when considered in the context of this conference, their sociocultural, economic, and political contexts. And of course, they are also these objects, which are designed in Denmark and assembled in California, are also closely connected to the object through which I'm talking to you, which, as we all know, is designed in California and assembled in China. So, what is it about these windmills? As I said, they fascinate me because they exemplify a history of design thoroughly embedded in social, cultural, political, and economic structures. They also fascinate me because, as I said, I've been researching the history of ecological design, and doing that normally means moving in spheres of kind of highly ideological realms. I mean, it's a field full of passion and enthusiasm and small scale operations and activism and environmentalism. But then it struck me that these windmills, they are an interesting example of how in a certain sense, kind of a paradigmatic example of ecological design went from experiments, tinkering, to a massive industry. So it's an important reminder that histories of ecological design is not just about this kind of ideologically driven, small scale, countercultural narrative. It's also about commercial applications and industrial scale operations. So why did Denmark become the world leader in windmill industries? Well, part of it has to do with the nation's industry supply, because Denmark is definitely the odd one out in a Scandinavian context. Whereas hydropower generates 95% of Norway's electricity and 45% of Sweden's electricity, Denmark had to find other solutions. As you probably know, there are not many waterfalls in Denmark, not many big rivers. And now, despite the recent surge in wind power development all over the world, wind power only accounts for about 5% of global electricity production. But in Denmark, that same figure has now reached 47%. That is half of the country's electricity is generated by wind power, which is by far the highest anywhere in the world. And this remarkable success story, as it is in a certain sense, is the result of a very complex process entangling technological, political, economic, ideological, and cultural developments. And also in Denmark, well, I should say that these kind of wind farms, as we see on this image, and what we consider, the modern day windmill technology or the windmill industry, is a very recent phenomenon. It's, for all intents and purposes, 40 years old. But there's a longer backstory, which is important in order to understand Denmark's position as a world leader in this field. Because in Denmark, the history of electrical wind power is exactly as long as the history of the power grid. Because the country's first power plant was opened in 1891. This was a diesel-powered plant, or a coal power plant. But in that same year, a physicist and educator named Paul Lacour constructed the first ever windmill, which was designed to generate electricity rather than grind grain or pump water, which of course windmills have been used for a very long time. But as an electricity technology, windmills was something new. And of course, his motivation for doing so was that Denmark was poor in terms of coal. It doesn't have any local coal resources, nor did it have any waterfalls. But on the other hand, it was very rich in terms of wind. So Lacour thought that if they could somehow tame the wind and the energy from the wind, then that could be Denmark's path to electrification and modernization. So Lacour was a teacher at Oslo College. And I should note here that there's these kind of schools where he taught is something called People's Colleges, which is a network of schools all across Denmark, which is not part of what we think of as higher education, and they don't grant degrees and such. But it's not part of the regular school system either. It's something in between. It's sort of a personal development idea that's behind these schools, and they're intended for kind of adolescents or young adults. But it's an important part of Danish culture, and there are many of them, and Paul Lacour taught at one of these. Let's see if I can get that. There we go. And he managed to secure governmental support to experiment with wind power. And this is in 1891. So he built the first windmill at this college. This is the one you can see to the right in this photograph. And then he secured some additional funding a few years later and built a second version, which is the one you can see to the left, built in 1897. And Lacour, being a physicist and an inventor, this building underneath the second mill contains also allegedly the world's first wind tunnel, which he used to conduct aerodynamic tests to find the ultimate blade profiles and so on for these mills. I should also note that the building of this second mill, the architectural structure, so to speak, was not designed by Paul Lacour. It was designed by an architect named P.V. Jensen Klint. It was one of his first jobs. And P.V. Jensen Klint, for those of you who are familiar with Danish architectural history, would become a pivotal figure later on, as he designed, well, his most important, well-known building is the Grentvik church in Copenhagen, which is considered a masterpiece in Danish architectural history. And the Grentvik church was built in commemoration of Grentvik, a theologian who basically founded this movement, or the foundation for these people's colleges. So there's that connection. And of course, also the architect P.V. Jensen Klint is also the father of Kåre Klint, which is considered basically the founder of modern Danish furniture design. So these might seem like anecdotes, but it's interesting because it shows how the windmills actually are embedded in Danish design history from the very start. It's just not been presented that way. So Lacour built these mills and conducted all of these experiments, and had a certain success with them. I mean, in the early 20th century, let's say the 1910s, a number of a few hundred of these mills were built across Denmark, based on Lacour's principles. Also, in 1904, they started offering courses in for what they called rural electricians, which basically was mill designers or mill maintainers. So this is an intriguing start, but it does have an important legacy, especially through these rural electricians. But these mills were soon made redundant in terms of commercial electricity production because diesel aggregates became cheaper throughout the 1920s. Local power plants would use diesel engines rather than and to a certain extent, coal fires rather than windmills. They just couldn't compete in terms of the economics of it. And following that, these experiments with wind power, they would pop up now and again, and normally in times of crisis. So, and crisis often means war, of course. So during World War I, Denmark became very volatile because their entire electricity supply was dependent on imported fossil fuels, mostly coal at that time. So electricity became scarce. And that's, of course, when clever people again turn to solutions like wind power. Another thing about World War I, of course, is that there was significant innovations in terms of aerodynamics, airplane technology. So a couple of Danish engineers figured that they could improve windmill technology using those kind of new innovations. So already a year after World War I, in 1919, engineers Johannes Jensen and Paul Winning developed this windmill that you can see on the left in this slide, called the Agrico Mill, which speaks to its context of rural electrification, that it was intended for agricultural use, basically. And they even got a patent for this mill. But then nothing really, I mean, some of these were built and they were used to a certain extent, but nothing much more happened really until World War II, when again, of course, the same problem resurfaced of shortages of imported fossil fuels. So again, local entrepreneurs try to solve this, again, looking at wind power. And this model you can see on the photo on the right in this slide is the so-called Fls Aero Motor, developed by two engineers again, Helge Claudio West and KG Soiten. And these were associated with the FL Smith company, which is basically an engineering cement company. And Soiten was associated with a small scale airplane manufacturer. A few of these were built during World War II. But again, as soon as the war was over, there were really not much incentives to keep. There was not much of a market for these things. But following World War II, the energy supply remained precarious, partly because coal prices were high, and shipping was in short supply. And this kind of continued well into the 50s, actually, and it was exacerbated by, for instance, the Korean War. So there was, in the early 50s, an international concern for the sort of energy infrastructure of Europe, basically. And the newly established Organization for European Economic Cooperation, OEEC, organized a series of meetings on wind power to kind of to examine the potential of wind power. And OEEC was, of course, also the organization which managed the Marshall Plan funds. And some of these funds were, because of this concern, directed into wind power research. And the Danish Ministry of Public Works, for instance, they granted 300,000 Danish kroner in 1954 to fund wind power experiments. And the guy who would be put in charge of these experiments was an electrical engineer called Johannes Juel. Johannes Juel was at this point an aging man, but he had, in 1904, attended one of these courses for for rural electricians at Oslo College, which Paul Lacour had organized. So there's a link, directly link, even if it's separated by 50 years, there's a direct personal link back to the kind of the first experiments in the late 19th century. And Johannes Juel was convinced that wind power had commercial potential. And he used this funding to do a lot of experiments and investigations into where the placement of windmills. He understood that that was crucial, of course, that windmills had to be placed in just the right locations in order to be productive. And also windmills had to be connected to the modern power grid, of course, in order to become part of a kind of a commercial scale solution. And perhaps his most important gains, though, was that he understood that a windmill had to be designed so as the ratios between wingspan, generator size, and the speed of rotation would have to be seen as a whole. And his calculations basically became the industry standard. So he started doing practical experiments already in 1947. He did wind tunnel testing of blades in order to search for the optimal profiles and rotor designs. And he concluded that airplane wings were actually a better model for windmill blades than propellers were. And based on this, he designed the kind of the 3-blade configuration, which would become the industry standard. And based on several years of experiments, he then eventually, in 1954, start work on what is considered basically the modern mill, the so-called Gedser experimental mill, which was then built from 54 and operational from 1957. And just to indicate the significance of this object, when the Danish government, some years back, I think it was in 2008, decided that there should be a cultural canon, an official cultural canon of Denmark. It was, of course, this was a conservative government who decided this, and it was ridiculed by a lot of left-wing cultural professionals, etc. But the interesting point here is that the cultural canon, they had a section for design, and it contained 12 objects. There's one for design, one for art, one for film, one for literature, and each consisted of 12 objects, I think it was. And for the official Danish canon, cultural canon of design, this thing here was selected as one of the 12 objects, alongside, for instance, the Flora Danica tableware, right, which is very different kind of object. So it's interesting how now, in recent years, this has actually been canonized as, formally canonized as an important piece of Danish design. And it is also a landmark, both literally and figuratively, also in the history of wind power. Johannes Juel was the Danish representative at these OEEC meetings on wind power. He became an international authority on wind power, and his writings have been used by later wind power entrepreneurs and enthusiasts ever since. And it was a success. It was a fairly simple design. For instance, he used what is called stall regulation, which means that he relied on the design of the blade profiles. They were designed in such a way that the mill would not run amok. I won't go into details, but it's inspired by aircraft wing designs, where you have this phenomenon called stall, which means that the blades, even if the wind velocity increases, the velocity of the rotor will not increase, which means that it can withstand harsh winds and storms. Whereas elsewhere, where they were experimenting with windmills, they relied on so-called pitch regulation, which means that you need a mechanism that can adjust the blades as the wind increases, and that's of course a much more complicated and therefore more volatile way of doing it. So Juel's reliance on simple, those kind of basic designs and solid construction is at the heart of what would become known as the Danish Concept internationally for windmill designs. And it operated from 1957 to 1967, that is for a decade, and produced 2.2 million kilowatt hours, and proved basically that a windmill could be part of kind of the commercial power grid and actually work. The problem, of course, was that by 1957, and certainly by 1967, the incentives that led the government to fund this and led Juel to design and construct this, they were basically gone. because by the late 50s and throughout the 1960s, fossil fuels were dirt cheap and a steady supply. So the Grentvik Mill and these kind of concepts could simply not compete in terms of the economics. So it was decided to shut it down. Yule was not happy about this, of course, because he thought that you can't simply look at, the price of a kilowatt hour of electricity. You need to and compare windmills to oil or coal-fired power plants. You need to think of the larger social economics of it all in terms of self-supply and in terms of environmental factors as well. And from the late 50s also, the solution was thought to be nuclear power. In 1958, the Danish government established a research facility that was going to explore the potential of nuclear power in Denmark. So suddenly the interest in wind power was reduced drastically. Of course, until the crisis hits again. 1973, the oil crisis hits hard. And because Denmark is still entirely relying on imported fossil fuels, Denmark is hit hard by the 73 oil crisis. In 1973, Denmark's electricity relied on 94% imported oil and 6% imported coal. Just to explain why the oil crisis hit Denmark so hard. So, for instance, for a period, they had to introduce car-free Sundays. You could not drive your private car on Sundays. So this press photo here, I think, is quite evocative of that, where children suddenly can play in the streets again without, being pushed to the side by cars. Also, by 1973, other things had happened. For instance, the environmentalist movement had grown strong. And the opposition to nuclear power had grown strong. So the public acceptance of this dream of abundant supply of electricity from nuclear power was deteriorating. So this changed kind of the premises once again. To understand how this could form the basis of an industry, we need also to look at kind of the organizational side of things, and the Organization for Information on Nuclear Power, which is an anti-nuclear power organization, was established in 1973, right after the oil crisis. And 2 years after that, that organization, along with other environmentalist organizations, established the Organization for Renewable Energy. And the latter would quickly become an important arena for startup windmill manufacturers and became a place where they could share information and experiences and knowledge. So both in terms of the energy policy and in terms of environmentalist concerns, the tables really had turned quite significantly since the closure of the Gedser experimental mill in 1967. And this is a course of only 7-8 years. And perhaps even more kind of symbolically, the RISA National Laboratory, which was built in 1958 to kind of propel Denmark into the nuclear age. 20 years after, in 1978, this institution was equipped with a department dedicated to windmill research. Also, the same year, 1978, saw the establishment of both the Association of Danish Wind Power Plants and the Association of Windmill Manufacturers. So combined, all these various initiatives created quite a comprehensive institutional framework for the budding industry. But there's another trajectory to this story too, and that is the countercultural mill. Because while politicians and organizations, utility companies and manufacturing industry gradually built a system that could soon make wind energy a commercially viable enterprise, there were also other independent actors which quite literally took matters into their own hands. And by far the most spectacular example of this type of DIY eco-design was the Twin Mill, which was built between 1975 and 1978 by a group of over 300 people. Teachers, students, activists, enthusiasts, and volunteers on the grounds of the Twin School Cooperative in Western Jutland. And standing 53 meters tall and featuring rotor blades measuring 27 meters and a 2 megawatt generator, this giant homecraft project was no less than the largest windmill in the world at the time. I won't go into details about that because it's somewhat of a side step in towards the kind of the industrial application of this, but it is quite a remarkable part of the history anyway. Here you see the gearbox that's going to go on top here, and it weighs 18 tons, just to give you a sense of the dimensions here. And this was done by this group of amateurs, basically. All right. But the commercial wind industry started on a smaller scale. So following the oil crisis, I mean, several countries invested significant resources in top-down, large-scale, prestigious windmill projects. And so did Denmark, Germany, and the US. But long story short, all of these projects failed. They could not make windmills that would be reliable. So one of the major explanations for Denmark's eventual success in this industry was that they started a bottom-up strategy. And one of it, part of this came from kind of local amateurs and enthusiasts. But a second strand, which would, become the most significant one in terms of the commercial side of it, came from small and medium-sized manufacturers of agricultural machinery and mechanical equipment, who just sensed a new business opportunity. So by about 1980, about a dozen such companies had entered the fledgling windmill market, including Vestas, Nordtank, and Bonus, all of which would become major players in the industry. Building well-functioning, commercially viable windmills was largely, at least at this early stage, a process of small-scale, craft-based manufacturing and assembly requiring practical ingenuity and basic mechanical engineering skills. So both in terms of available machinery, tools, know-how, and company culture, these outfits thus proved well-placed to develop what was arguably an entirely new product category for an entirely new market. So this is how they succeeded. Whereas, for instance, in the US, most windmill experiments was conducted by, they involved NASA and Boeing, Westinghouse, and these kind of, major research and development facilities, which were not content with this kind of very low-key approach. So when finally a viable home market emerged in the late 1970s as a result of strategic policy development, economic incentives, and organizational support, it was unique even in a global context. The only other country where there was anything resembling a commercial market for windmills at this point was in the US, or more specifically, the state of California, where major tax breaks and predictable purchase agreements with utility companies made wind farms a lucrative investment to the point of earning the moniker the Great California Wind Rush in the first half of the 1980s. The handful of Danish manufacturers who made it through the startup phase and dominated the growing home market quickly began looking west for expanded opportunities, starting with the export of 40 windmills to California in 1982, a number that rose to approximately 360 already the next year, and further to 1,600 in 1984, and a remarkable 3,000 in 1985. By 1986, Danish manufacturers had captured 70% of the booming California market. As noted above, the US manufacturers had not succeeded in developing reliable designs, leaving Californian clients more inclined to bet on the dark Danish horses appearing on the horizon, carrying suitcases filled with impressive statistics on operational stability and production figures. The Danes had proved that they could make this work, basically. So here you see what's largely considered the first standardized windmill, the Vestas V15. Because, of course, in order to meet this crazy demand from California, the Danish manufacturers had to scale up, and they had to scale up fast. So before this, windmills was basically, built one after the other in a very kind of craft-intensive way. So they had to grow and grow up fast. So Vestas, for instance, the manufacturer of this, and which eventually would become the world leader, they responded by building a new factory, and the number of employees grew rapidly from 200 to 1,000. And of course, the quest for ever improved efficiency and profitability resulted in a gradual increase in the size and effect of mills. So whereas the first Danish mills, which were exported to California, such as these, were equipped with 55 kilowatt generators and rotors about 15 meters in diameter, the industry worked hard and fast to develop mills with 100 to 130 kilowatt generators and 20-meter rotors, and then larger still. But the Danish manufacturers led the way not only in terms of reliability and functionality and standardization, but also in terms of design in a more conventional sense. And as is often the case with new technological products, aesthetics is a low priority in the early phases, but becomes increasingly important as both product and market mature. In the words of one industry commentator at the time, quote, "Many of the turbines built in California in the early 1980s looked and operated like losing entries in a children's erector set competition," end quote. But then came Danish design. Vestas and Bonus pioneered the tapered tubular tower design, which we now know as the standard, which replaced these kind of lattice towers which had dominated that far. And also the increasing attention to the visual appearance of windmills became apparent also in the design methods that they applied. So the industry, they established proper design departments and proper design procedures. So designing windmills gradually became less intuitive and more systematic, relying to an increasing degree on sanctioned knowledge, theory, and research. So the windmill manufacturers' bootstrapping approach to design gradually attracted the attention of what we usually think of as the professional design community, moving the object typology from the generic realm of engineering design into the more self-consciously labeled category of industrial design. So in 1984, the Danish Design Council organized an idea competition for new windmill designs, motivated by the ambition that Denmark should add a design advantage to its technological lead in the industry. That's just to show what one of these more professionally designed windmills looked like in the mid-1980s. But perhaps the industry's design cultural recognition at home, at least, reached a new threshold when another model from the same era, the Dunvin 24180, received the ID award from the Danish Design Center in 1988. So at this stage, windmills have become a design object, if you will. Also, in 1993, another manufacturer, Nordtank, approached the esteemed design consultancy Jacob Jensen Design, who many will know as having established Bang & Olufsen's design profile, and commissioned them to design and develop one of the largest commercial wind turbines in the world at the time, which was 100 meters tall. And which would later go on to win the IF Award and the Red Dot Award. The recognition of windmills as objects of design is not restricted to the professional realm. However, gradually they have become signifiers of Danish identity, of Danish cultural heritage, and of course, icons of ecological design. So a kind of a symbol of this process, in 2007, the Danish Postal Service released a series of of commemorative stamps designed by Bertil Skov Jørgensen, featuring 4 by then considered iconic windmills. And you see up to the left here, the very first one, the Paul Lacour designed at Askov in 1891. And then, of course, the Gedser Mill. And then to the bottom right here is the Middelgrunden, which is the first offshore wind farm in Denmark. And perhaps even more indicative of the windmill's kind of cultural position in Denmark and its role as an icon of design came a few years ago when Lego launched this set of a Vestas wind turbine, firmly establishing the windmill as kind of an iconic feature of Danish design history. So I've run out of time, so I'll stop there with this image. Thank you.
Kjetil, thank you so much for this fantastic presentation, which swept us away with the windmills, I would say. And it's so nice how you actually managed to windmill designs in this intersection of social, cultural, economic, political context, which beautifully fits into the conference, and also this eco and sustainable idea, which we started to discuss yesterday when we spoke about ceramics art and design. So we can see how everything is intertwined. We are lucky to have 10 minutes for comments or questions. So please use any tool available. You can ask your questions raising your hand. You can use our chat here. And I'm following our YouTube channel, which, yes, there are no questions or comments yet. Okay, let me see if yes, we do have a question from Irina. Good morning, please. Okay. Yeah.
Morning, and thank you very much for your lecture. Very refreshing, I would say. It kind of vented us into various spaces. As Ludmila said, the ecological topic and political one, reminding of the reliance on nuclear power, which didn't work, unfortunately. And but I wanted to ask you a question of about the design. When it's a general question, and perhaps nobody has an answer yet, but I want to discuss it with you. When does the object become the object of design? No, it's because you finished with your last picture of Lego, of the Lego windmill. Doesn't happen when actually it's included into the Lego set.
I guess it depends what you mean by an object of design. I mean, for me, it was an object, or it is an object of design from the very start, and that's not only because, as I said in that anecdote about architect P.V. Jensen Klint, that there actually was professional design expertise involved from the very beginning. It's just that we don't really know about it. But I would say that even if that were not the case, it would still be an object of design, whether it's, conceived of by a physicist or an architect is ultimately of less interest to me, at least, because these things are significant features of our material culture, of the built environment, and that makes them objects of design. But of course, if you understand a design object more as sort of the way the term is used in mainstream media, then of course it's different. Then of course these markers that I mentioned towards the end, that a certain windmill model gets a design award, or that Lego makes a model, then those markers kind of become more significant. But that speaks more to me, that speaks more to the kind of the cultural appreciation of it than, so it depends kind of what you understand by an object of design, I think.
Yeah, thank you.
Thank you, Kjetil. We have a question from Trine. Good morning.
Hello, and hello, Kjetil. Nice to see you again.
Likewise.
I have a question about Windmill, because I find these histories of counterculture very interesting. And I was curious how you came upon this, this piece of history. Was it covered by media, or did you uncover it any other way?
The twin mill was extensively covered by the media at the time. But of course, they started building this thing the year I was born, so I didn't follow that in the media at the time. So I actually discovered that story, what was it, about a decade ago, in a book, which actually written by one of my former supervisors. A great book, by the way, called Tinkers, Rebels, The People Who Shaped Europe, which is kind of a bottom-up history of technology of Europe. And it's just a brief mentioning of the twin mill, but they included in this broader history of kind of a consumer's perspective on the history of technology, to show, you know, what engaged citizens can do. And I was deeply fascinated by that story then. So when I decided to do some research into the history of Danish windmills, I mean, that was the place I started, basically. But it was covered both in mainstream media, and it was also covered in like professional media, in engineering journals, etc. Because although it was kind of an amateur project, the school itself wanted to portray it as an amateur project, but they did rely heavily on expert help from the Danish University of Technology, for instance, and also from the LISA research laboratory, which they weren't too keen to emphasize, of course, because it didn't fit their image. So yeah, it's a deeply fascinating story. And there's also more to the countercultural part of this, in which weren't as crazy as the Twin project, but several of these other people's colleges around Denmark actually did build windmills, and often did so in collaboration with, there was a couple of young architects who published a handbook on wind power in 1976, and these were engaged by the people's several of these rather radical people's colleges to construct windmills, and also solar heating systems, etc., on these college buildings. So that's an important part of the history, which I didn't have time to cover now.
Thank you. That's very interesting.
Thank you, Kjetil. I hope, yeah, there will be a chance to cover some other aspects of the histories, which are fascinating. Again, thank you so much for this contribution. It's a fantastic start, very beautiful, very refreshing. I agree with Irina for the second day of our conference. And I think it's time we move, and our next panel, which is actually, which continues its work, because we started the panel Art and Design Modes of Corporeality, which this year is focused mostly on the touch and the tactile. I don't think we need any further explanation why. So the only fact that we are here, not face to face with each other in the university proves how the tactile is important and has become immensely important for the recent year.